Hello everyone. So, we will continue with constant tension winding test. So, as I have mentioned that it provides conditions somewhat similar to actual processing conditions during winding, warping, sizing. Basically, the most of the breakages occur in the yarn during these processes, winding, warping and sizing. After that, obviously in weaving also, during weaving, during picking. So, in most of the cases we will see the system is that it is winding or unwinding type situation, except warp which gives the almost static loading. Okay. So, and after that, after warp, we will see when once fabric is made, then the yarn strength does not actually, it is not that important, single yarn strength, then comes to the fabric. Okay. And in that case, if we see that majority of the process, the running of the yarn undergoes the winding, warping and sizing, and this gives the direct indication of the efficiency of a particular yarn in the its impact of that yarn on the efficiency of a particular machine. Yarn with a very high strength, if it breaks during the winding, then it will actually affect the efficiency. So, that is why it is important to know the running condition, okay, the strength in running condition. So, A, B as I have mentioned are fixed pulleys, P is a movable pulley. Under static condition, the load is divided into two equal parts, and when tension is imposed, it got extended, stretched by E. So, the speed we know that it is basically input speed multiplied by 1 plus E times. Okay. And we have to arrange some means, so that it can take care of the stretchability, and if we know the stretch percent, then we can easily adjust the speeds, and standard breakage rate is 8 breaks per 1000 yard of yarn. Now, if we know this standard breakage rate, then we can adjust this load, and that load will be the dynamic load of the yarn. Dynamic load of the yarn means at load say P, the yarn gives 8 breaks per 1000 yard. That means it is a P is the dynamic load. If it gives more than that, then we have to reduce the load, okay, till we get this value. That means higher the value of P means better is the yarn. And suppose we are having a load, say lower load, much lower than P. In that case, if it does not break running smoothly, that means we are not getting any indication. Similarly, that in a static condition, if the yarn does not break, if the material does not break, then we will not get the strength. Similarly, dynamic strength only we will get if it breaks repeatedly, and that is the 8 breaks per 1000 yard, the load. The tension required T to get the standard breakage rate of 8 breaks per 1000 yard is measured. Okay. So, if it is higher than 8 breaks per 1000 yard, then we have to reduce the load to bring it to such a value which gives exactly 8 breaks per 1000 yard. Now, there is a relationship. Now, the relationship is that for a yarn, N1 is the breaks per 1000 yard at tension T1, So, this is the in x axis it is a tension, running tension. Okay. So, tension we are giving T 1 and N 1 we have got the value, and y axis is plotted the log value of N 1, it is a log N 1. So, there is a straight line relationship between the tension and the logarithmic value of number of breaks per 1000 yard. So, for T 1 tension there is a breakage rate of N 1 which is have value. So, log n has been put here. Similarly, for tension T 2 the breakage rate N 2 breaks per 1000 yard. So, this is the plot T 2 tension and log N 2. Now, if we plot a straight line curve, this is actually straight line, from there we can get any value, any unknown value. So, in that case we can actually predict what will be the number of break at what tension, that is the indication that will get almost indication which is actually which works. Here the system is that the thing we cannot get in this instrument, we cannot get 8 breaks, getting 8 breaks per 1000 yard is impossible. It takes large number of testing, it will take longer time, because we do not know. Suppose we one unknown tension we have given, suppose it is coming say 50 breaks per, another unknown tension we are giving say 30. So, how long will we go? We cannot go infinite time. So, to get exactly 8 value, that is why the system is that we test the yarn in 2 different strength tension value T 1 and T 2, which will give us some values of n. So, T 1 test at tension we know N 1 we have reached. So, that means log N 1 we have put, T 2 we have increased tension to T 2, we have got higher N 2 value, then log value we have put, and simply we have put the straight line. Now, what we have to reach here? We have to reach the value standard value, which is nothing but 8 breaks per 1000 yard. Now, to reach this 8 breaks per 1000 yard, that means log of 8 value we will take y. In y axis we will find where is log of 8. This 8 value x equal to 8 if it is standard, then we can simply tell this is the t value. T value is the which we actually want to know, that is the t value which from which we can compare. This is the standard rate breakage rate t, and the slope of the curve is that it is a log n 2 minus log n 1 by log n 2 minus log, this is the y, this height divided by this distance divided by T 2 minus T 2, that is the slope tan theta. So, slope of this curve we can get, which is constant, and so this is here, and standard value any standard. So, for BS standard it tells it is a 8 breaks per 1000 yard. For any other standard, any known value, suppose for our purpose we want to know at what tension the breakage will be 1000 or 100 breaks. So, we can simply calculate, we can get the value, extrapolate the value. Okay. So, this is the standard value. That means, if our standard is x 8, so we can calculate the tension required T for to get the value 8 using the simple formula straight line. Okay. This is what is that? It is nothing but y equal to m x plus c. So, we know this a value, that constant here, from there we can calculate. Okay. So, we can calculate the required tension, if we know, if we want to have any other any known value, or vice versa also. If we know the tension, we can predict how many breakage will be there, that is also important. Here in this test, if we can plot for a particular yarn, if we can plot this curve using T1, T2 and N1, N2, if we can plot, then this will help us in setting the tension, in winding, warping or sizing. So, we can come to know that what will be the probable breakage at that. So, if we set the tension T, so then we know there will be x breakage per 1000 yard. So, from there we can predict. So, this will give us a clear idea of the performance of yarn during running. Now, there is a empirical equation. This empirical equation gives a relationship between the dynamic tension, with the static strength. This is a beautiful equation which will solve many problems. I will discuss one practical problem. So, and this sigma is the standard deviation of single yarn strength. So, here this is the probably the only equation, empirical equation, which gives the relationship between the dynamic strength versus static strength, where K is the constant which depends on the n number of breaks and changes with the length of the single, with the test length. So, this K value, it changes with the number of breaks and test length of the single yarn strength. So, this K value depends on both in static mode, that is static mode, what is that? It is a test length, gauge length, and in dynamic mode it depends on the number of breaks. So, K value it changes, but for as per Brit, so this value static mode. So, this gives one relationship between static and dynamic. That means, if we know the breaking strength for a particular gauge length, which will give us idea about K value, and if we know the variability of the yarn strength, then we can come to know the tension required to for a certain number of breaks. That means, here if we see this standard deviation, that means for keeping other x for a particular yarn, a yarn with a certain mean strength, this is a mean breaking strength. If we increase the standard deviation, suppose variability of strength is increased, then what will happen? This will give us the idea about that this value will reduce, this time T will reduce. If we change the variability, that is standard deviation increases, that the T value will reduce. That means, the n number of breaks per 1000 yard will occur at lower tension. That means, yarn strength is, yarn performance is poor, lower at lower tension it will break. Similarly, if the yarn strength is high, keeping the standard deviation constant, that means our tension required for certain number of breaks will be more. So, in BS standard handbook, the first estimate of tension required to produce 8 breaks per 1000 yard. So, that is 8 breaks per 1000 yard is the standard breakage rate, and they use this formula. What is the formula? T equal to average yarn strength multiplied by 1 minus Cb% of single yarn strength by 30. This is given in British Standard Handbook, BS Standard Book. And if we specifically follow this, now what are we reaching? This it is x bar, that means single yarn strength, T is the tension required for standard break of 8 breaks per 1000 yard, okay. And C, what is 1 minus what is Cb? Cb is nothing but standard deviation by x bar multiplied by 100 divided by 30, and if we see this becomes x bar minus 3.3 standard deviation. What does it show? That k value becomes 3.3 here. K is 3.3 here for a particular situation, as we have mentioned that gauge length. What is the gauge length? In BS Standard Handbook they say the test length should be 20 inch and N value we have mentioned earlier. So, N is 8 breaks per 1000 yard. So, only for test length 20 inch and 8 breaks per 1000 yard, if we consider, then the known value is for k is 3.3, and if we do not know, if we change all these values 8 and 20, then k value will be different. So, if we want to use k as 3.3, then you have to set this value. We have to set the gauge length for this static test, and we have to set the T value that breakage rate in T in such a fashion that breakage rate becomes 8 breaks per 1000 yard. Only in that case the k value will be 3.3. Now, try to see one numerical here. This numerical it is basically it takes care of many concepts, and we have to see very carefully to solve this problem, and this will give us clear idea about the application of the practical application of this tensile tester, this tester. And here if we see that what is it telling here, the tenacity of a yarn 29.5 Ne cotton yarn at 4 inch gauge length is 15 gram per tex. So, here condition 1, at 4 inch gauge length tenacity here it is a 15 gram per tex, 15 gram per tex, okay, at 4 inch gauge length, and the what is the yarn Ne 29.5 Ne yarn. So, we can convert it to Ntex Nt, the tex we can convert this one, and if we multiply this, what we will get? We will get the strength, we will get the mean strength x bar. Okay. So, at the question is that at what tension, okay, it is given the whatever the question is that we have put in pink color. Okay. At what tension, in constant tension winding test, the breakage rate will be 20 breaks per 1000 yard. So, the requirement is that at tension we want to get and for 20 breaks per 1000 yard. Okay. And assume the standard deviation of the single yarn strength is always 20 gram, standard deviation is given, it is constant, and another condition is that we have tested the same yarn which gives the 200 gram tension, gram force tension, the breakage rate is 0.5 breaks per 100 yard. So, at 200 gram force tension, the breakage rate is 0.5 breaks per 100 yard. So, this is, that means there are 3 conditions. One condition is that the yarn is tested in at 4-inch gauge length, it gives the breaking stress at 15 gram per tex, okay. And what we want, at what tension the breakage rate will be 20 breaks per 1000 yard. Okay. Now, try to solve in stepwise, try, let us see, and this is the equation as we know. Okay. This is the required tension and standard, the value of breaking, that number of breaks. Now, T 1 equal to 200 gram, that is T 1. Here we are trying to take, this is T 1. Okay. Last condition, this T 1 we are trying to get. So, 200 gram and it is 0.5 breaks per 100 yard, means 5 breaks per 1000 yard. So, this will become N 1. So, this parameter is known. So, for everything, for any calculation, as we know, we have to know the two data point. So, T 1 is straightway given. Now, T 2 how will you get? So, we want to measure T and x value. So, this is we want what tension T value, this is we want, and x value is given 20 breaks per 1000 yard, x is here 20, that is known, but we do not know the T 2 value, we do not know the N 2 value, that is. Now, how do we get? To get, because we have to have 2 data points. So, one data point is straightway given, now we have to find another data point. Now, for that data point there is some clue here given. Tenacity is given at 4-inch gauge length, it is a 15 gram per tex. That means 15 gram per tex is a static mode of tension, static mode. So, the equation which we know this equation in earlier slide we have shown in the static mode, this k value T, this 3.3 is only valid with the 20-inch gauge length. This k value only we can use for 20-inch gauge length, and this 8 breaks per. So, in that case, if we consider N 2 as 8 and if we can calculate the T value, this will become T 2, and clue is that here we have to, we do not know other k value, we know this k value, that means we have to get x bar, that standard deviation is given constant, but we have to get x bar with the as per BS standard result. What is BS standard? BS standard says that it is a 20-inch gauge length, but in our case the x bar is at with the 4-inch gauge length. So, here it is a 4-inch gauge length data is given. Now, we have to get the data, this strength with the this strength with it is a 4-inch gauge length, we have to get this data with 20-inch gauge length. That means, how do you do? In last class we have discussed that with the change in gauge length how to measure, how to get the strength, how the strength value changes, okay, that we will use here. Now, N 1 is known, this is the value. Here this k value we have assumed, we have taken this, we have to use this equation. Okay. We cannot. So, here N 2 is fixed, N 2 is as per the standard, N 2 is fixed 8. Now, we have to get the T value, this T 2 value. So, gauge length is known. So, this x bar is the mean breaking load at 20 inch gauge length. If we can get this x bar value, then the T value will be T 2 value, and standard deviation here it is given 20 for all the condition, always standard deviation is 20. So, we will use this here T value, the standard deviation T, sorry, this 20. Now, this minus 3.3 into 20, that is minus 66, okay. Minus 66 is it is fixed, we know this is, but what about x bar? Now, we have to get the x bar. To get x bar, we know the value 15 gram per tex is given. So, from there we will try to get the value breaking load. So, 29.5 Ne means 20 tex yarn, and at 4 inch gauge length the breaking load. Now, breaking tenacity was there 15, now we are converting it to breaking load 300 gram force. Is it x bar? It is not x bar till now, because here gauge length is 4 inch. We have to convert this gauge length to 20 inch, then only the whatever breaking load will be the x bar. Now, breaking load at 20 inch gauge length. So, we will use earlier equation, that is S R L with R is nothing but 5, 20 by 4, 20 inch by 4 inch, R equal to 5. So, we will use this formula here. In this formula, we know the all this value except this R L, okay. S L is known. So, S R L we have to calculate, that means at 20 inch gauge length, at 4 inch gauge length the breaking load was 300. So, S L by S R L equal to 1 minus 4.2, this will bring it to left hand side, okay. So, we will just interchange 1 minus 4.2, 1 minus 5, r equal to 5 to the power minus 1 5, and this value, what is the V by 100, CV% by 100 means the this standard deviation by mean value. Mean value means 300, it is a mean breaking strength 300. So, V is nothing but V by 100 is nothing but 20 standard deviation by mean strength. Okay. So, that means it is coming out to be. So, you can see CV% is nothing but standard deviation by mean into 100. Here V equal to sigma by x bar into 100, or sigma by x bar is 300 into 100. So, basically it is 20 by 300 into 100. So, V by 100 we can write as a 20 by 300. Okay. So, that is it is replaced here. So, 20 by 300. So, if we calculate this value, we will come out to say the ratio of SRL and SL becomes comes out to be 0.923. So, SL, what is SL? SL is nothing but the mean strength at 4 inch gauge length, which is 300. So, SL means it is coming out to be SRL, it is 300 multiplied by 0.923, it is 277. What is 277? This is the strength, breaking strength at 20 inch gauge length. Now, we have reached that value, that is, this is nothing but the x bar in this equation. So, now we can get the T value 277 minus 3.3 multiplied by 20. It is coming out to be 211 gram force, which is nothing but T2 value. Okay. Now, what we have got? T1 we have got, N1 we have got, T2 we have got, N2 we have got, and we know the value N2 is 8 breaks per 1000 yard. So, T1 is 200 gram force, N1 is 5 breaks per 1000 yard, it is given, and just now we have calculated T2 equal to 211 gram force, N2 is 8 breaks per 1000 yard, that is a standard we know, and x we know the x value, this x value is known, it is a 20 and then we have to calculate x is 20 breaks, that is the question, at what is the tension to get 20 breaks per 1000 yards. So, x is 20 and we have to calculate this T value, and using the simple formula, the same formula we can use. So, 200 T1 plus 200 T2, 211 minus 200 multiplied by log 20 x minus log N1 is 5 divided by log N2 is 8 minus log 5. So, this if we just simply solve, we will get the value which is equal to 233 gram force. So, that is the actual result. So, what does it show? So, for if we know the basics of this test methods, we can calculate any data, anything, provided we have some raw data, and condition here is that here what we are trying to see, we know the statics load. Okay. If we have two dynamic load value, then it is a little bit simpler, but if we have say static load, then if we do not know the k value, there we have to use the BS standard. So, known standard, then we will go for 3.3 value, and with the condition, then we have to use the exact condition and gradually we have to proceed. Okay. So, that is this is a typical problem one can solve, and in industry the applicability is that we can set the tension, because otherwise if we set wrong tension, then it will affect the unnecessarily affect the efficiency of machine. Okay. So, we can set, okay, that is the result. Now, the application here, the results serve as a guide to the behavior of the yarn in subsequent process. So, it will give us the guide. So, if we know the breakage rate for a particular tension, that will give us the probable end breakage in the subsequent process, end breakage in warping, end breakage in winding or sizing, and accordingly we can set the tension. Okay. It gives an idea, and comparison of yarn quality. So, we have two yarns. Basic problem is that the weaving industry or some processing industry, they purchase yarn from the buyer, okay, supplier. Normally, we do not test this test, and we get the sample by knowing the tensile test, okay, in static mode, tensile test. The problem is that yarn with higher tensile test value if it gives the higher breakage rate, then it affects the actual the efficiency of the subsequent process. That is how. So, if we see here 3 ions are there, ion A, ion B, ion C. Now, which ion is actually I have to purchase. If we get, if someone tells, I will definitely will go for this ion, it is a higher CSP, okay, higher single ion strength. If we say which one is stronger ion, higher CSP and higher single ion strength, it is good ion, without testing the dynamic mode. Now, once we test the ion in dynamic mode, then our decision will be entirely different. In dynamic mode, if we see the result, although ion B has least CSP, means count strength product, least CSP, it gives least the breakage rate. That means, the ion B is expected to give higher efficiency, a lower stoppage during running, okay, at least 3 times. So, ion A, although it is giving higher CSP or higher strength, its breakage rate is 3 times higher than this almost. So, that means it will give poor performance. Okay. This ion B and ion C also it gives poor performance. So, as far as the performance is concerned, the one should prefer the ion B, okay. And the strength, if we see, it is not that low, it is, although it is lower than the ion A or ion B, but it is not that low, it is workable. But if we take the ion A with higher CSP and strength, its performance will be poor. Next is that single ion strength testing. UTM, universal testing machine, is used, which works in the that strain gauge principle, and normally standard gauge length is 50 centimeter gauge, 500 millimeter, okay, and speed is adjusted so that the time to break is 20 plus minus 3 second. That is the, you have to adjust the speed. So, in that, during that time it breaks. Now, after single ion strength, another strength measurement is there, another type of strength, it is a Skene method, it is a Lee strength testing. The advantage of Lee strength testing is that at a time we can test longer length, larger length, size of length, okay. Typically it is a 120 yards of length of yarn, we make a Lee and we test. So, it tests a longer length of yarn in one test, okay. But in normally in other single yarn test, what we do? We test smaller test and number of sample we have to test. Second advantage is that the yarn is expected to break at its weakest spots. So, the Lee is prepared and this yarn in single yarn strength it breaks once, okay, at its weakest spot, but once that Lee, it is in Lee form, it is continuous Lee form. So, it will start breaking at different point. Okay. Now, the thing is that suppose it is a single yarn strength, so it breaks at this point, but if it is Lee, large number of rep. Now, this is what we are doing, these are the jaws, this is top jaw and this is bottom jaw. Okay. Now, here this yarn has got different weak spots. different weak spots are there. In single yarn strength there is only one weak spots. We do not have any idea about the other weak spots which are little bit stronger than this point. We are not getting any idea. It breaks and that is at the end of the test. But here the advantage is that depending on the position and the location of the weak spot and the strength of the weak spot, this will start the yarn will start breaking. First this weak spots break, then this will break, this will break. So, depending on the strength this will break. So, this will give overall idea of the weak spots, different weak spots present. Okay. If the number of weak spots are more, then the least strength will be least, otherwise it will not stop at the particular weak spot. Suppose in that yarn only one weak spots are there, only one weak spot. That means, even after breakage of that weak spot, the test will continue. Yarn will also have certain strength, the strength will increase, okay? The strength value will increase. So, that means, one weak spot will not basically give us the total, it will not stop the test. So, yarn is expected to break its weak spots, so that it gives more realistic strength value. It will not stop there. Okay. That obviously, the same hank we can use to measure the yarn count. Now, the hank which we had say 120 yard we have used here. So, this is say 120 yards of Lee, this is 120 yards, and here we have got certain strength. Okay. In terms of say kg we can get, in terms of pound also we can get. Okay. Now, here the value, the term comes CSP. CSP is nothing but count, strength, product. Okay. Now, why is it product? Why not it is a division, count, strength, division? Why not it is a something else? Basically, the thing is that here the breaking load, here it is expressed in terms of pound. One should be very careful. This CSP is nothing but product of breaking load in pound LB multiplied by the yarn count in NE, no other unit. That gives us idea about CSP. Now, why the concept of CSP comes from the Lee strength, the yarn strength in skein form. Okay. It is not the single yarn strength, not in the other any other form, not in the form of say bundle or nothing. It is only you have to have a yarn Lee of 120 yard. Okay. That means, breaking load of yarn Lee in pound multiplied by the yarn count in NE, that gives the idea of the that value of CSP. Now, the thing is that you can see the value here CSP is nothing but the strength in pound and NE count is NE. So, S multiplied by N, say NE. Now, this value a yarn, say we have prepared a yarn from a particular cotton, from a particular variety of cotton. Okay. particular variety of cotton, and we have got a count of say 30 Ne, and we have got a strength of certain strength, say strength of say 60 pound. So, what will be the value CSP? 60 into 30, 1800. Typically CSP does not have any unit, we do not use any unit, it is a CSP, count strength product, and it is known, it is a pound and Ne. Now, this 1800 value, what does it indicate? Why is it product is yarn? Now, from the same variety of cotton, same cotton and same set of machines, I am producing say 25 count yarn. So, if I produce 25 count yarn, in that case what will happen? 25 count is it coarser or finer? It is a coarser count, coarser than 30s count. Okay. So, it is a Ne is 25. Now, what is the expected load value, breaking load value? The expected breaking load will be typically say around 70 to 72, definitely it is, we have to have this expected, so that it's the value product it is coming out to be exact very close to 1800. That means, if we make the yarn finer, the strength, if we make the yarn finer by increasing the value, then the strength value will proportionately reduce. Okay. If we make the yarn coarser by reducing the Ne value, the strength value has to so from 62 it has to come to 72 or 70. So, that we get this value. Now, what will happen if we assume, if we are producing say 25 count and we are getting a value of say 60 or 65. So, 65 pound we are getting for 25 same cotton we are using, and we are instead of 30s count we are now producing 25 Ne, but we are getting 65 pound. So, I would like to know whether this 65 pound is perfect or not, because earlier it was 60 pound, now it has increased, we have made it coarser 30 to 25, and from 60 it has become 65. Okay. Now, should I be happy with that? Just to have this indication, we will multiply these two and we will definitely get value less than 1800. Okay. It will give value much less than 1800, that means it something is wrong with this yarn. Now, what does it indicate? It indicates that the process, the manufacturing process of this yarn 25 count yarn, there is something wrong, because we have used same cotton with similar production line should result same CSP value. So, for certain variety of cotton the CSP value should be almost same, that is the indication. The importance of CSP one must understand very carefully. It gives an indication of the performance of your machine. Okay, that is one aspect. That means, if we change the count little bit, if we change suppose 30s count a cotton, a variety of cotton say V1, V1 variety cotton, okay, it is meant for 30s count, and we know this cotton will give, if the machine performs perfectly, optimum a perfection, it gives a CSP of 800. That means, the variety of cotton, its indication is 800, 1800. 1800 shows the nature or quality of the cotton. If you, and this will give us an indication, this particular variety of cotton will be used for this count 30s count, around 30s count. Now, if we reduce the count, make it 25 count, it should give the value 1800. Now, suppose now for this cotton variety V1, is it true that if we produce any count, this will always give 1800 CSP? No. Suppose with this variety, this means 30s count, it is a medium variety cotton. Now, if we try to produce yarn of 60s any very fine count you want to produce, will it give us a strength of 30 pound, least strength of 30 pound, so that we can get 1800 CSP? No, it will not give. This variety of cotton, if we which is meant for 30s count, if we try to produce 60s count, it will give a much lower value, say 10 or 15 or 20 pound strength it is producing, and 16 it is 1200 CSP. That means, it is we are actually trying to overuse this. We are not trying to use the actual potential of this machine. This cotton is meant for 30s count range, around 30s count. If, and this cotton is actually will give us 1800 CSP. Okay. Now, we are using another superior variety of cotton, very high quality cotton, superior variety B2 say, which gives a CSP of say 2400 CSP, and which is meant for say 80s count, around 80s count. This 80s count yarn, it is there, then we will give this this variety of cotton is meant for 80s count. If we produce, then we will see it will require say 30 pound, approximately 30 pound least strength will give, and we can get 2400. Now, suppose we are trying to produce yarn of very coarse count from this variety. From this variety, we are trying to produce say 10s count, 10s count. In that 10s count, can we expect that we will get a strength of 240? 240 strength will not be there. 240 strength, it will be lower than that. That means, there is something wrong in it. Our selection of cotton is wrong. CSP, although it is a very simple term, but it talks about too many things. So, it gives the indication of the variety of cotton. Like when you are going to purchase a cotton, they will tell, okay, this will give us a CSP of say 1800 CSP, that means you know the your quality, and this yarn is within range of say 30, around 30s count. This cotton is for 30s count cotton, and if that particular cotton, if everything is right with the cotton, everything is right with the cotton, if you still are not getting 1800 CSP, that means your machine, there is some major problem with your machine. Okay? That means that it also gives the optimum count possible. Okay? It will give us idea about the machine performance, it will give us the idea about the range of count we can produce, it will give us the idea of the either whether we do overspinning it or underspinning it, all this idea it will give. So, that is why this value it is approximately constant for a particular variety of cotton, it is not the unique pair. If you change the variety, it can range from say maybe 1000 or 800 CSP to say 3000 CSP. And if it is asked that yarn we are getting 800 CSP, another yarn we are getting say CSP of say 2000, which is having with a better cotton, that means definitely 2000 CSP is with a better cotton. Okay. But with a better cotton, if we try to produce coarser count, as we have seen, it is not giving the higher CSP. So, CSP, the CSP value indicates the overall performance of the spinning machine. Okay. So, main disadvantage of this technique is the result depends on the friction between yarn and also between the yarn and hook. So, if the yarn to yarn friction is changed, keeping the yarn same, if the yarn to yarn friction changes, then the yarn, the CSP will change. It is a very common example. A normal cotton yarn if we take and the same cotton yarn if we scour, the least strength, that is the CSP value, the least strength value will change. Okay. That is the, so the CSP is normally it is taken in the raw form, raw cotton form, and no measure of strength variability. So, strength variability we know, we do not know, we get the overall strength value. Okay. And we will stop here. In next class we will start the fabric tensile test, okay, with the strip tensile test. Okay. Till then, thank you.